Hi everyone. Here's our lesson on 4-3. We're talking about congruent triangles today. Let's first define what congruent triangles are, and it probably won't take too much understanding for you to get what congruent triangles are, because you know what a triangle is. A triangle is a shape that has three sides and three angles, and congruent means same size and same shape. So two triangles that are the same size and the same shape. So here's what I want you to write down in your notes here for today. That congruent triangles are triangles with congruent corresponding sides and triangles with congruent corresponding angles. So what I have written down right here is called a congruent statement. This is a congruent statement. So when it says that triangle ABC is congruent to triangle XYZ, this triangle right here is the exact same size as this triangle here. They are congruent triangles. And like I said, in a triangle there's three sides and there's three angles. So technically speaking, each angle, this word corresponding right here, is congruent to its corresponding angle, or each side is congruent to its corresponding side. So this angle A right here, let's say for example it's 30 degrees, its corresponding angle, which is angle X in this triangle, is congruent. It's also 30 degrees. If this angle right here is 100 degrees, angle C, angle Z corresponds to it, so it would be congruent to angle C. And the same case with B and angle Y. So this congruent statement, it might seem a little bit insignificant, but it actually means a lot. And here's what I mean by that. And I would encourage you to draw this in your notes as well. Draw an arc from A to X. Because A is the first point in triangle ABC, that's as it's written there, triangle ABC, and X is the first point in triangle XYZ. So the letters that are written first, the points that are written first, those angles are the ones that are congruent to each other. So B is written second and Y is written second. So those are the corresponding angles that are congruent. And then the same thing is true of angle C and angle Z. So that's what this information is saying right here. The first letter A is congruent to the first letter X. AX. The second letter B is congruent to the second letter Y. B is congruent to Y. And then Z and C. Okay, so that congruent statement really means a lot because it's telling us which angles are congruent to their corresponding angles, to their matching parts. Now the congruent statement also tells us which side lengths are congruent. Because like I said, every triangle has three angles, but every triangle also has three sides, and they are congruent to their corresponding sides. So notice how AB, those are the first two letters. So AB is this distance right here. And the first two letters in this one are XY. So AB is congruent to XY. And that's what this says right here. AB is congruent to XY. Notice how BC is the second side length that's written in our congruent statement. And that side, BC, is congruent to the second two letters, or the second 2 points right there, that segment at YZ. So that's where it says segment A, or BC is congruent to segment YZ. And then in the same way, the first and the third letters is the last segment in this triangle. AC is congruent to XZ. So here's AC, it's congruent to XZ. So for there to be congruent triangles, the three angles have to be congruent to the three angles in the corresponding triangle, and the three sides have to be congruent to their corresponding sides in the other triangle. And then you have congruent triangles. With congruent triangles, these congruent transformations, there are three of them. There is a slide transformation, a turn transformation, and a flip. Notice what the slide looks like. So I have a blue triangle and I have a green triangle. And the The blue and the green are congruent. Notice how they are the exact same size and the exact same shape. And a slide transformation is kind of where the direction of the triangle stays the same. It just moves to a different location. So you can kind of see how I'm just moving the location, but the triangle is kind of facing the same direction, if that makes sense. So this is called a slide transformation. Next one is called a turn transformation. So notice again, I have a blue triangle and I have a green triangle. And you see that center point? That's called the center of rotation. And it's just going to rotate around the center of rotation. So this is a turn transformation. Some people call it a rotation. So it's rotated like 180 degrees, for example. Okay. I also want you to notice that the matching or corresponding angles might look a little bit different, even though this angle, if you can kind of see the very right angle on the blue triangle, you see where that arrow is pointing, its congruent angle, its corresponding angle is the left one in the green triangle where my arrow is pointing. So this angle is congruent to this angle. Be aware of that. Even though triangles might be facing a different direction, you got to make sure that you're very careful on which angles are congruent to each other. In the same way, what side lengths are congruent to each other. Now, another thing I want to say here is that the center, we could rotate triangles around any point. Maybe the center of rotation is right here. Now it's going to rotate around that center. The center could even be inside the shape, for example, and we could rotate it around that point. So this transformation is called a turn. And then our third one is called the flip. This one is where it kind of like, it's called a flip because it kind of flips over a line. So for example, this blue dotted line, this blue triangle going to the green triangle, it flips over it. So once again, I want you to be aware that this angle, the bottom angle right there of the blue triangle, its corresponding part is not in the bottom of the green one, it's actually the top angle in the green one. These two, where my arrows are pointing, are corresponding angles. So be aware of that as you're doing some problems with congruent triangles. Now I could flip a triangle over any line I want to. I could flip it over this line, for example, and now it looks like this. I can make my line completely vertical, and now it flips, and it looks that way. So I could, there's many different lines of reflection here, for example, for it to flip over that line. All right. So it says verify that triangle QRS is congruent to triangle Q prime R prime S prime. We're going to be getting to this a little bit later on. When I said this Q prime R prime S prime, this little dash right here, it means the word prime. This is oftentimes called the image. And so then what we start off with is called the pre-image. We'll get to that a little bit later. But right now, if I want to verify that QRS, that triangle, is congruent to Q prime R prime S prime, I basically want to prove that angle Q is congruent to Q prime, angle R is congruent to R prime, and S is congruent to S prime. I also, there's three sides and there's three angles to every triangle. I also want to prove that side QR is congruent to side Q prime R prime. I want to prove that side RS is congruent to the side length for segment R prime S prime. And I want to prove that QS is congruent to Q prime S prime. So there's 6 things that I need to prove. 3 angles are congruent to their 3 corresponding angles, and 3 sides are congruent to the 3 corresponding sides. So what I would recommend that you do here is that, so what I would suggest that you do on this one is that you would plot the points QRS and plot the points Q prime R prime S prime. And again, the first thing we would want to do is prove that the 3 sides are congruent to their 3 corresponding sides. On a coordinate grid, how could you find a side length distance of QR? Well, hopefully you're thinking, I would use the distance formula. Now I'm going to save some time here in our video lesson where I'm just going to find all the distances, but you guys could find the distance of all 6 parts. 3 side lengths in the red triangle and 3 side lengths in the bluish purplish triangle. So here we go. I'm going to find the side lengths. So Q prime, S prime, so like this. And I'm going to find the side length measurements for my red triangle. And we get this. Alright, so are my corresponding side lengths congruent? My side lengths from R to S is 4.18, and my side length from R prime S prime is 4.18. Well, notice how my corresponding side length is congruent. So that's good. Q prime R prime 5.32 and QR 5.32. So a second side length is congruent. And QS 6.09, Q prime S prime 6.09. So my 3 side lengths from one triangle are congruent to my 3 side lengths in another triangle. So I'm well on my way to verifying that these 2 triangles are congruent. So the first thing I'm going to write down here that I want you guys to write down is that QR is congruent to Q prime R prime. And RS is congruent to R prime S prime. And these are lengths, they're segments, you should be putting lines over them. And then my third side length, QS, is congruent to Q prime S prime. We can verify that using the distance formula on my sketchpad document. I already did that for us. So we're halfway there. We've proved that 3 sides are congruent to the other 3 sides. Now we have to prove that the 3 angles are congruent to the other 3 angles. So I'm going to go back here again. And we want to prove that Q and Q prime are the same degree measure. R and R prime are the same degree measure. S and S prime are the same degree measure. How would you do that? You would find a protractor and you would measure all 3 angles of one triangle and all 3 angles of the other. Again, to save time, I've already done that for us in this sketchpad document. So notice how angle Q is 42.27 and Q prime is, Q is 42.27 and Q prime is also 42.27. We have the measure of angle R is 78.69, R prime 78.69, and angle S 59 degrees, and S prime is also 59 degrees. So we have successfully proved that those 2 triangles are congruent. We have verified because we proved that the 3 side lengths are congruent to their corresponding side lengths, and we proved that angle Q is congruent to angle Q prime. We proved that angle R is congruent to angle R prime, and we proved that angle S is congruent to angle S prime. If the 3 side lengths are congruent to their matching side lengths, their corresponding side lengths, and the 3 angles are congruent to their corresponding angles, the 2 triangles are congruent. So now it was named the transformation. What is the transformation called where it kind of flips over the y-axis? Well, it's called a flip. When it flips over a line, the congruent transformation is called a flip. Okay, so now we're going to get into 2 proofs. Remember how we did algebraic proofs, where we did these 2-column proofs where we had a statement and had a reason? We're going to use this same 2-column proof to prove that 2 triangles are congruent to each other. So with this given information, we want to prove right here that triangle ABC is congruent to triangle DEF. Well, with our given information, the very first thing we want to do is we want to mark up our picture. So, angle A, let's put 1 arc there. It's congruent to angle D. So let's put 1 arc there. Angle B is congruent to angle E. So I'm going to put 2 arcs at B and 2 arcs at E. And then C, I'll put 3 arcs, and F, I'll put 3 arcs. Alright, and now the next thing that we need to mark up is it says that the segment AB is congruent to segment DE. So here is AB, and it's congruent to DE. I'll put 1 tick marks at both of those lengths. Segment BC and segment EF. They're congruent to each other. And then segment AC is congruent to segment DF. We'll put 3 tick marks there. What do you need, class, to prove that 2 triangles are congruent to each other? You need to prove that the 3 angles are congruent to the 3 corresponding angles, and the 3 lengths are congruent to the 3 corresponding lengths. So we need to prove that 6 pieces of information are congruent to the other 6. And our given information gives us all of that, so we can simply write the proof by this. The very first thing we always do is we write down the given information. So all of this, let's write down as our statements, and our reason for all of those 6 is that they are given. So angle A is congruent to angle D. That's step number 1. Step number 2, angle B is congruent to angle E. Step number 3, angle C is congruent to angle F. And then we have our lengths, our segments. Segment AB is congruent to DE. And we have BC is congruent to EF. And our last one, AC, that length, that segment is congruent to segment DF. All right, and for all 6 of these reasons, why do we know that? It's because that is given to us. All right, so now once you know that 3 angles are congruent to their 3 corresponding angles and 3 segments are congruent to their 3 corresponding segments, we can now know that the 2 triangles are congruent to each other. So yes, proving that ABC is congruent to DEF, we know that. So our last step, step number 7, is we write down triangle ABC is congruent to triangle DEF. Once we've proven the 6 corresponding parts are congruent to the other 6 corresponding parts, we're done. We write down our proof. ABC is congruent to DEF. And why? The reason why this is because that is the definition of congruent triangles. The definition of congruent triangles is that the 6 corresponding parts are congruent to their other 6 corresponding parts. So that is the reason that we have for step number 7. Let's try one more here. This time we have our given information of these 5 pieces of information, and we want to prove that triangle ABC is congruent to triangle FEC. So let's first mark up our picture. That's the very first step. Angle 3 is congruent to angle 4. I'm going to put 1 arc at 3, 1 arc at 4. Angle 5 is congruent to angle 6. Angle 5 and angle 6. And then we have AB. That segment is congruent to segment EF. We have AC is congruent to FC. And we have BC congruent to EC. All right, so we want to prove that the 2 triangles are congruent. Just for the sake of another picture, we want to prove that this red triangle is congruent to this green triangle. Well, to do that, we have to prove that the 3 angles are congruent to their corresponding angles. So angle 3 and angle 4 correspond. Statement 1. Angle 3 is congruent to angle 4. That's given. Let's write down the other 4 pieces of given information. Angle 5 is congruent to angle 6. The first thing we write down is all the given information. AB is congruent to EF. Segment AC is congruent to FC. ACFC. And BC is congruent to EC. All right, so it looks like to prove triangles are congruent, three angles have to be congruent to the other three angles, and the three sides have to be congruent to the other three sides. So we're missing one piece of information. We're just missing these angle 1 and angle 2. If angle 1 and angle 2 are the exact same degree measure, we can say that the two triangles are congruent because 3 is congruent to 4, 5 is congruent to 6, and the three sides are all congruent to their corresponding parts. So are 1 and 2 congruent? If they are, bam, the two triangles are congruent. If 1 and 2 are not congruent, then the two triangles are not congruent. So class, are angle 1 and angle 2 congruent? The answer is yes. Why are angle 1 and angle 2 congruent? Angle 1 is congruent to angle 2. Why? What is our reason? The reason is because they are vertical angles. And vertical angles are congruent. So that's what you write down for step 6. Angle 1 and angle 2 are congruent. Now, step number 7, you prove that the three angles are congruent to their corresponding angles, and the three side lengths are congruent to their corresponding side lengths. So now we end up with writing this: triangle ABC is congruent to triangle FEC. And the reason why that is because it is the definition of congruent triangles. So that's our video lesson for today. Let me know if you have any questions when you get to class tomorrow.